Hello, and welcome to a lesson on ray diagrams for plane mirrors. After watching today's video, you should be able to draw ray diagrams for plane mirrors and be able to calculate the image position and height when using a plane mirror. So let's get right into this guy. A ray diagram is basically a diagram that traces the path that light takes in order for a person to just view an object of an image on a mirror. Okay, so if you go stand in front of a mirror, we could really trace a ray diagram from you to the mirror, and it would show how the image is being created in the mirror. Rays are represented by lines in ray diagrams, and objects typically are going to be represented as arrows, oddly enough. So it's not like we're going to be drawing, Mickey Mouse here, or Michael Jordan or something like that. We're just basically going to be using arrows to represent our objects, and then we're going to draw ray diagrams from these arrows. Okay, and this will make a lot more sense when I do an example problem with you guys in just a second. Okay. So there's 4 steps basically to drawing a ray diagram. Okay, and so what I'm going to do is I'm just going to draw it right here, and I would encourage you guys to draw this in your notes with me. But this is a mirror, and typically mirrors will have like these lines behind it. This is to show that this is a mirror. And I'm going to draw an object in front of the mirror. And then, so here's my arrow in front of the mirror. And I'm going to draw an image directly behind the mirror at the exact same distance from the mirror. Okay, so I'm going to ballpark this. It looks like it's about that far. So if I were to draw the image of this object, and maybe I should use a different pen color just to kind of make this a little easier. We'll use green for the image. So make this arrow be green, and this would be the image that is being created from this red arrow. Okay, so that's step 1, is draw the image of the object. So you put an arrow in front of a mirror, and now you have an image of that arrow. Okay. Step 2 is pick one extreme on the image of the object and draw a reflected ray that will travel to the eye at its sight point. Okay, so sometimes these directions will seem a little intense or confusing, I guess would be a better word, but don't worry, it's not so bad. So if I draw my mirror here, okay, and put those lines there, here is my arrow, okay, and then my reflected arrow, we were using green, right? So I'll draw my reflected arrow here, which would be back here. Okay, so what this basically says is pick one extreme on the image and draw a reflected ray that will travel to the eye's sight point. So I'm going to draw a head right here. Okay, this is supposed to be a head. He is, or she is, looking at this arrow. Typically, the rays that are behind the mirror, because they're not really real, they're just pretend, they're going to be represented by dotted lines. So I'm going to draw some dotted lines coming at this mirror, and once you pass the mirror, now this is a real light ray, it will travel to this guy's head. Okay, and so this is a reflected ray that I'm drawing right here, and then these dotted lines are just basically imaginary lines, if you will, but this is to show that it's producing the end of this point of this arrow. Okay, so I'm just going to draw a little arrow right here and call this a reflected ray. Okay. So that's step 2. Okay, I picked one extreme on the image. I could have picked the other end of the arrow if I wanted to, but I picked this end of the image of the object and draw a reflected ray that will travel to the eye's sight point. Okay, or this head is what we're using for this image. Okay. Step 3, and this kind of stinks each time I have to redraw all of this, so bear with me here. I apologize that there isn't a more efficient way to draw this. So this is my mirror. Okay, mirror here. This is my arrow in front of the mirror, and then our reflected arrow was green, so it's right here. I'll try to make this equal distance. When doing these problems, just as a side note, using a ruler and a pencil is not a bad idea because you can make straight lines, you can erase, you can do all those great things with a ruler and a pencil. So I recommend that for these problems. Okay, so this dude's head's right here, and basically we had a dotted line drawn directed towards his head, and then once the light wave ray reflected off of the mirror, it was a solid line. Okay. Now, what they're asking for is to draw the incident ray of light traveling from the corresponding extreme on the object to the mirror. So I picked the point, the end point of this arrow. I'm going to pick the end point of this arrow and draw what's called an incident ray. Okay, and I'm going to put an arrow on it indicating its direction of travel. Okay, so this is the incident ray. Here's the reflected ray. And I'll label those just to keep everyone clear. This is an incident ray. Incident ray, and this guy here is the reflected ray. Okay, so did this follow the law of reflection? Well, absolutely, right? If I draw the normal here, if I draw a normal here, this angle right in here should equal this angle right in here. Okay, and so now I've created the end point of this arrow as an image. Okay, so that's step 3. Now step 4 basically has you repeating steps 2 and 3 for all extremes on the object. And the beauty of arrows is that you really need to do this twice because you need to get one end of the arrow and the other end of the arrow. So if I were to do this whole shebang all over again, let's do a black screen. That sounds exciting. Here's my mirror. Okay, and I'm going to do it all in one color just to keep things simple. So here's an arrow. Okay, it's in front of the mirror. Now the first step was to draw this object about an equal distance behind the mirror. So I'm going to do that here. Okay, so this is the object, the real thing. Okay, and this is the image. Okay, here's this person's head. Okay, he's looking this way. All right, and the first thing you do is you pick one extreme of the arrow, and you're going to draw the reflected ray from that arrow. Okay, so if it's behind the mirror, it's a dotted line, and I'm going to be heading towards this dude's head. Okay, and once I get past the mirror, and if you want to put a little arrowhead on it, you can, like to show its direction of travel. That's fine. Then I'm going to put a solid line going right to this guy's head right here. I'm just making this bolder so you guys can see that a little better. Okay, so that's the reflected ray traveling this guy's head. Then what I'm going to do is from this point here, I'm going to have it match up on the object. Okay, so this is going to be, oh man, that was horrible. Sorry about that. That's the incident ray. That was really bad. That's the incident ray, and it's coming from this tip of the arrow. And why did I pick that tip of the arrow? Because I picked the tip of the arrow in the image. Okay, and so that's 1 point. And again, if I were to label this is the reflected ray, and this guy right here would be the incident ray. Okay, now step 4 basically says rinse and repeat. Do it again. Okay, so if I were to do it again, I'm going to pick the other end of the arrow down here, and I'm going to have it come to this guy's head. And this is where a ruler would come in really handy, because I just put my ruler at this end of the arrow and have it lead to this guy's head, and I would draw a dotted line behind the mirror, and then a solid line. Oh, well, sorry, that's not. I got excited that I actually drew it straight, but it didn't turn out. So that's the, again, this is my reflected ray right there, and again, it's dotted because it's behind the screen. And then all I'm going to do is just match up where I got that from on the image to the arrowhead, or the back end of the arrow. I don't know what that's called. And I'm going to draw a line. Man, let's see if I can get this without messing this up beyond belief. Gosh darn it. That is supposed to go to the back end of this arrow. This is going to be a tough lesson for you guys to watch. All right? So ignore that mistake right there. This line right here is kind of a mistake. But this line right here is the incident. Incident, spell it out right. Incident ray. Okay, and that's a ray diagram for plane mirrors. I'll be honest with you, we're going to do a lot of these because we're going to be talking about different types of mirrors and lenses, and you're going to be drawing these ray diagrams a lot. So I recommend investing in a good ruler and a good pencil in the near future so that you can do these and you can see how many mistakes I made and where erasing would be able to be very nice to be able to do. Okay. One last slide to talk about. Actually, I lied. 2 slides to talk about. The images formed in plane mirrors are pretty self-explanatory. Okay, to see yourself or to view an image of yourself in a plane mirror, the amount of mirror you need would equal 1/2 of your height. Okay, so if you are say a 6 foot tall person, a 6 foot tall person would need a 3 foot mirror in order to view his entire image. Okay, and the amount of mirror, and I thought this was kind of interesting, the amount of mirror needed does not depend on how far or close you are to the mirror. So as long as this 6 foot dude had a 3 foot mirror, he could stand like directly in front of it and be able to see himself. Or he could stand like 10 feet behind it and still be able to see himself. Kind of interesting. So that's one property about plane mirrors, is that the images, you just need half of the mirror or half of the height of the mirror of whatever the object is you're trying to look at. Okay. So with these plane mirrors comes some mirror equations for the image position. Okay, so the image position, how far is it from the mirror? It's real simple. We have, let me change colors because I feel like green is kind of hard to see. We have negative di equals do. Okay, real simple. And all this is basically saying is that the distance of the image, so the image being produced in the mirror, is equal to the distance of the object. Okay, so this stands for image distance, and this guy right here stands for object distance. Okay, so if you put a pineapple 3 feet in front of a mirror, the image produced is going to be 3 feet behind the mirror. You may say to yourself, well, Mr. Reddy, why is there a negative sign here? The negative sign indicates that the image is what's called virtual. And basically a virtual image is one that forms behind the mirror and is not in front of the mirror. Okay, the light rays themselves don't actually go to that point. Okay, it's a virtual image, right? For plane mirrors and their image height, so how big is the object in the mirror, it's also pretty simple. The height of the image, hi, and I'm not just saying hi to you guys, well I guess I will, hi, hi equals ho, okay? So basically whatever you're saying is the image height, so let's say you have a 3 foot tall object, it's going to be 3 feet tall in the mirror. Okay, this isn't one of those like funhouse mirrors where you look really skinny or stretched out or something like that. Basically, your height is going to equal the image height, or the object height is going to equal the image height. Okay, so that takes care of this video. I will see you guys next time.